Alright guys, welcome back for more chemical equations. This is going to be a short tutorial on how to balance equations. So the first thing I need you guys to know is that in my class there are two rules for balancing equations. The first one is obey the law of conservation of mass. This means you are not allowed to create atoms and you are not allowed to destroy atoms. Rule 2 goes like this: never, ever, 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 ever change a subscript. So just like in a recipe, you're not allowed to just randomly change things out because it'll mess up your product. Same deal with balancing equations. You can't just change subscripts, because when you change a subscript, you end up changing the ingredient or you end up changing the product. So just please never, ever, ever, ever change a subscript. So the worksheet that I'm looking at right now is the one where you hopefully yesterday spent a little bit of time looking at the different reaction types. And we are going to do the first 4 questions together, making sure that we obey these two rules: keep the law of conservation of mass and never change a subscript. So question number 1 looks like this. You should have some mercury oxide, and then on the opposite side of that arrow, you have things that look like this. So for this one, I do want to use some props to help you think about this. Mercury oxide is going to be my reactant, and mercury with some oxygen gas are going to be my products. So just doing a quick glance down the middle, here I have one mercury atom, here I have one mercury atom. So it looks like I'm obeying the law of conservation of mass there. But here I have one oxygen, here I have 2 oxygens. This is bad. We cannot create or destroy any atoms, so we have to fix it. So the thing that usually happens next is people are like, aha, I just need to change the number of oxygens, and the first thing they want to do is go over here and write in a little 2, because if we wrote in a 2, well then my problem would be fixed. But if I write in a 2 right here, I am breaking rule number 2. Please never, ever, ever, ever change a subscript. So the thing that we're going to be doing instead is adding in coefficients, just like this is algebra class. The only place where coefficients can go are at the front, at the very start of any reactant or any product. The coefficient is going to multiply. It will distribute to everything in that reactant or product, but the coefficient is stopped by the arrow and it is stopped by a plus. So on the front page of your worksheet, you will notice that we have written in lines for you. After I do these example problems, if you never use the lines again, that is a-okay. If you like the lines and you like writing them in, by all means, go ahead and do that. But the only thing I am ever going to grade on one of these problems are the numbers that go in front. I will grade you on whether or not you got correct coefficients. So the things that I use these lines for is just doing a quick count beforehand. So as this equation is written, I have 1 mercury and 1 oxygen on the reactant side, and I have 1 mercury and 2 oxygens on the product side. So mercuries match, oxygens don't. So I need to get more oxygens on this side. As we already discussed, changing the subscript is not a thing. So what you need to do is put a coefficient out front. And when you do that, it changes both of the atom types that we've got. I now have 2 mercuries and I have 2 oxygens. If it is helpful to remember that there are invisible 1 subscripts and that your coefficient is multiplying them, go ahead and sketch them in, but try to avoid that as much as possible. So now, my mercuries don't match and my oxygens do. So instead of adding a subscript, remember to add a coefficient and make it match. This too does not modify this oxygen because it is stopped by the plus sign. Now my numbers match on both sides, and this is the answer to question number 1. So to look at it pictorially, here's what we would have. we would have 2 mercury oxides, we would have 2 mercuries, and 1 oxygen molecule. The last thing to discuss on this question is the fact that there is a line out front where you are supposed to have determined which type of chemical reaction: synthesis, decomposition, single replacement, double replacement, or combustion. If you take a look, I have one reactant that is breaking apart into 2 smaller things. So when you break things apart, we call that a decomposition reaction. Question number 2. We have some silicon dioxide and some magnesium doing a chemical reaction to produce some silicon and some magnesium oxide. Again, for these early problems, it's often helpful to write in the lines and do this initial count up of all of your atoms on both sides of your reaction arrow. So over here I see 1 silicon, 2 oxygens, and 1 magnesium. On the other side I have 1 silicon, 1 oxygen, 1 magnesium. So it looks like my problem is going to be with my oxygens. Again, the thing that people usually want to do wrong is they usually just want to change the subscript. They don't like writing the coefficient because the coefficient changes 2 things, and they think to themselves, but I just want to change 1. But please don't give in. Don't change those subscripts. So when I add the coefficient, I now have 2 magnesiums and 2 oxygens. So now silicon match, oxygen match, and magnesiums don't. So I need a 2 right here to fix my magnesiums. Everybody matches. I have obeyed the law of conservation of mass. I did not change any subscripts. So the last part is we have to tell which type of chemical reaction this is. So if you're looking at it, you can see that magnesium has come and it has bumped silicon out of the way, and it has paired up with the oxygen. So magnesium partners with oxygen, silicon is by itself. So if something is getting a new partner and something is ending up by itself, we call it single replacement. The other thing I usually like to note on this problem is a lot of people want this to be MgO2, but the reason it's just MgO is because magnesium likes to form a +2 cation. Oxygen likes to form a -2 anion. These guys cancel each other out, so we don't actually do the crisscross to get the 2 and the 2. So just because you have a subscript on the reactant side does not mean it will be the same on the product side. The third question on this one involves a pretty complicated CH compound doing a reaction with oxygen gas to give us some carbon dioxides and some waters. So when we do the count on this side, I have 5 carbons, 12 hydrogens, 2 oxygens, and on the other side I have 1 carbon, I have 2 hydrogens, and I have 2 plus 1 is 3 oxygens. So usually balancing in the order that they appear is going to be a good strategy for you. So I've got 5 carbons. On this side I need to have 5 carbons. One other common mistake that happens on the balancing of equations is people try to add coefficients instead of multiply. So the only number that's going to get us to 5 here is 5, because 5 times the invisible 1 gives us the right number. But remember that it has to distribute to everything that comes after it. So 5 times 2 is 10 oxygens, plus the 1 oxygen that's still living over here, for a total of 11 oxygens. My carbons now match. My hydrogens, on the other hand, do not. So I need to figure out what coefficient goes here to give me a total of 12 hydrogens. If I place a 6 there, 6 distributes to this 2 to give me 12 hydrogens. But now I've also got 6 oxygens in this location and 10 oxygens in this location for a total of 16 oxygens. So the last thing I need to do is make my oxygen tallies match. the number that needs to go out front is the number that makes the total 16. So 8 times 2 is 16. And there is my balanced equation. This is the only part that I grade besides the reaction type. So for this one, a lot of people like to call it single replacement because they see, ooh, a compound and an element. But I want you to notice that everybody on this side has a partner, so it is not single replacement. The tip-off here is going to be the oxygen on the reactant side, which makes this a combustion reaction. So problem number 4 is not super challenging, but sometimes people get a little bit stuck on how to notate it when they have to make changes. So if you're someone who likes the lines, as we go through, you'll notice I have 1 potassium, 2 oxygens, and on this side, I have 2 potassiums and 1 oxygen. So usually what happens is people come along and they're like, I will make my potassiums match. Good. So that worked out. But then they get down here and discover that they need to get more oxygens as well. The only way to get more oxygens on this problem is to put a coefficient out front. 2 times the invisible 1 gives me 2 oxygens, but then they're up to 4 potassiums. 2 times 2 is 4, which means now we have a problem over here. This 2 coefficient is no longer correct. So please don't try to do weird things where you're writing 2 times 2 or anything like that. All you're going to do is erase whatever number you had and write the correct number out front. Obviously, you will not scribble yours out. You will just erase it and then write a 4 in the usual spot. Because I had to get out a brand new sheet of paper for this, I am going to do one more bonus problem. Let's hop down and do number 13 right after we discuss the reaction type here. So you would be correct in noting that 2 elements coming together into one big thing would qualify as synthesis on this, but you would also be correct to note that oxygen on the reactant side gives me a combustion. So I would accept synthesis or combustion on this one. All right, now for number 13. For those of you who are not algebra fans, sometimes you can get a little bit stumped on problems that look like this, where we have a problem balancing out 3 versus 2. So again, if you like lines, you do not need to do these lines, but if they are helpful for you, please go ahead and write them in, making sure that you always write them in the same order on both sides. So my counts are 1, 1, 3, and 1, 1, 2. So looking at this problem, the best way to do this, since my problem is with my oxygens, is to find the least common multiple and then make both sides equal to the least common multiple. So the least common multiple of these guys is going to be 6 and 6. And then I go up here at the same time and I ask myself, how do I make both of them 6? Over here, I need to have it be a 3. And over here, I need to have it be a 2. So now these guys match, but I do have to change my counts to 2 and 2, which means over here, I also need a 2. So if that works for you, that's probably the best way to do it. It is possible to go through and just make each side bigger. If you noted at the start that this side was bigger than the product side, you could have just gone and increased this from a 1 to a 2 and then increased back and forth. But again, the best way to do it is to find that least common multiple. So the reaction type on question number 13, if you have one large thing breaking apart into pieces, we are going to call this decomposition once again. As you work to finish this worksheet, I would want you to note that there is at least one question that is already balanced. So as you're going through and you're getting stumped by that, don't panic. There is one that is already done. And I will be posting the key for this probably soon. Talk to you later.